Hello everyone, welcome to the next lecture on the PY question series. Today I will explain you 50 plus questions related to the singularity topic. I will cover all those questions from the CSIR net and the GATE examination in this video. Myself Dr. Harish Garg, you can find me on my YouTube channel where you can find the playlist of the CSIR UGC net. In this playlist you can see the various lecture related to the PY question series. All are available with the help of the shortcut. I hope you can subscribe my YouTube channel to support my efforts as well as the videos. Now, whenever there is a concept related to the singularity asked in the examination, then the first thing come in your mind is always about the zeros and the pole. Remember, whenever there is a zero, you always think about the numerator of this function. Whenever there is a pole, you always think about the denominator. How you can find the zeros? That means you have to find the roots of the numerator part, and the pole means you have to find the roots of the denominator. Fine. Once you can find the roots, how you can find roots? If, for example, if my polynomial, if my period is this, then you can easily solve this. This will give you my plus minus iota. But if this is not in the form of the polynomial, it will be like of this manner. Then you are unable to find the roots by using this quadratic form, cubic form. In that case, you can use the concept of the numerical analysis. A function is said to be of the order m at the point alpha if the mth derivative is my non-zero while all its preceding derivatives are my zero. That means if I say f of z at z is equal to 1 has order 2, what does it mean? That means the second derivative at the point 1 is my non-zero, while the first derivative at the point 1 is 0 and the function itself at the point 1 is 0. Another thing, whenever you have the function of this uh, complex number, that's f of z, you have to find all those points at which the function is not analytic, and that function is called as the non-analytic, and that point is called as the singularity. How you can find that? You can substitute denominator as a 0 and the numerator as my infinity. Find all those points after solving these two equations, and that point is called as my singularity. And apart from this singularity, the function is said to be analytic. And the function which is analytic apart from the singularity point is called as meromorphic function. What is the meaning? Now this singularity is categorized into the two parts, that is the isolated and non-isolated. What is the meaning of the isolated and non-isolated? A point z is equal to z0 is said to be the isolated singularity if it does not include any of the other singularity points. Like, what is the denominator 0? You can see z is equal to 1 is my singular point. Then, is there any other singular point occurs? No. That means if you consider the circle of any delta, it does not involve any other singular point. That means that point is called as the isolated. If all those points which are not isolated is called as the non-isolated singularity. Isolated singularity is again discretized into the three categories. And this is the backbone of this today's lecture. That is a removable, pole, and isolated. Every time in the examination, a question will ask from these topics. Now you can check about the removable singularity. I will tell you the two different methods. The first method is by using the definition. If you find the Lorentz series of the function f of z, and if you find that there is no negative term involved, that means the bn coefficient of the bn are my 0, then we call as the removable singularity. If you find there are the finite number of the terms, then we call as the pole, and if there are infinite number of the terms, then we can call as the essential singularity. For example, if I write this is 1 over z, then clearly say if I expand this by the series of the exponential, and you can see these are the infinitely many terms of the negative power of the z. That means this is my isolated singularity. Similarly, if you write like of the sine of z, then clearly say it again it is my up to the infinite term, but we need a finite term. This is the first method. But I always suggested you can opt by this second method, that is a quite interesting and easy for you. Any point is said to be the removable singularity if you find the limit and if it exists finitely. What is the meaning of the existence? That means limit is my unique. Remember that you have to watch my PY question series of the limit. You must watch about my the PY question of the limit to understand the meaning of this existence. On the other hand, if you find the limit as a infinity, then you can say it's a pole. And if you say limit does not exist, what is the meaning of the limit does not exist? That means not unique. Then you can say it is my essential singularity. And this is the three method I have used throughout my this lecture series. On the other hand, if you find the limit point of the numerator, if you find the limit point of these zeros, then the point is called as the isolated essential. If you find the limit point of the zeros of the pole, then we call as the non-isolated essential. Make sure once you prove that it's an essential singularity, then you will check about that the limit point. If you find the limit point of the numerator, then called as the isolated. If you find the limit points of the denominator, then we call as the non-isolated. Another very beautiful shortcut tips for you: whenever you have a function, complex function pz over qz, if you find the zeros of the p, if you find the zeros of the q, then you can say at the point z is equal to 0 is called as a pole if this condition hold, otherwise we call as the removable singularity. On the other hand, if you want to find the singularity at the point z is equal to infinity, there is interchange of these results. Pole when m is less than 1, m is less than n, then pole when m is greater than n. And you can see this one. How you can check the singularities of this? This is another very important concept for you. How you can find the singularities of these kind of the functions? Always remember my shortcut tricks. You can find the singularities of the fz. This singularity is maybe the removable. This singularity may be the pole, or this singularity may be my essential. So if I say the point z is equal to z naught is my removable singularity of the fz, then then this function also has the same removable singularity. On the other hand, if I say z is equal to z naught is my pole, is the pole singularity of the fz, then this implies this z is equal to z naught is my essential singularities of these all cases. Similarly, if it is essential singularity, then z is equal to, again is the essential singularity. Make sure you have to remember this. If it is a pole of the fz, then sine, cosine, hyperbolic, exponential has the essential singularity. The last concept is if you have the entire function that is an analytic function, then the limit will be g infinity if it is a polynomial. If it is a finite, then it's a constant. If it does not exist, then we call as the transcendental function. If you want to find some another lecture on the complex analysis PY question, you can watch by this playlist, and all these are available at my YouTube channel. If you are new to my YouTube video, you can subscribe and like and comment on these videos, and you can scan and join my WhatsApp group as well. So now let's start with this PY question series. Remember, first question is you have to talk about the Z is infinity. Fine. Now, firstly, whenever they are talking about the essential pole, always find the limit whatever the point is given to you. Z is equal to infinity of fz. What is the answer is? Infinity. That means if this is infinity, that means it will give you the pole. But he said analytic. Fine. This is infinity, pole. Fine. This is infinity, essential, wrong. Remember, always essential means when this limit does not exist. Fine. Now we can see about, so first and third option, fourth option cancel. Now we can check about the limit at z is equal to 0. This value will be f of z is my z cube. It's a 0. What does it mean 0? That's a unique and existence. Once it's a unique and existence, what does it mean? That means this is my removable singularity. But he said pole. This option is also cancelled. Only left option is B is my correct answer of this problem. And you can see within the 10 seconds you can get your answer in a simple manner. This is the first method. Second method is you can, whenever there is a target at infinity, you can convert into the 0. How you can convert into the 0? Change the function to be 1 over z. So that is 1 over z cube. Now clearly say the pole of 1 over, so pole means denominator as a 0. If you substitute denominator as 0, then it is of order 3 because the power is my 3. So if z is equal to 1 over z has this, that is implies also is of the pole 3. So again the right answer is B is my correct answer. Now again you are talking about removable, essential, non-essential. Firstly, check about the limit at this singularity. What is the value of this? It will be my cos z minus sine of z. So clearly say when you substitute cos infinity, any number which are lies between -1 to 1. Sine infinity is any number lies between -1 to 1. That means limit does not exist. Once the limit does not exist, that means we call as the essential singularity. Removable is cancelled out. None of this is cancelled. Essential singularity is the right answer of this problem. Look at this one again, the essential pole and this. You can find the limit at the point z is equal to 0 of fz. Fine. Clear? If it is a unique, then we call as the removable singularity. If it is a infinity, then we call as a pole. If it is does not exist, then we call as the essential singularity. Now can you find this limit? It is a 0 by 0 form. So what you can say, it is a sine is cos of root z into derivative of this divided by 1 over root 2 root z, limit z approaches 0. Clearly say this quantity will be cancelled, cos 0 will be 1. That is my unique number. So unique means removable singularity, rest of the options are cancelled. Always remember, whenever the question is related to the singularity, always compute the limit first. I hope you can like and comment on my video to support my effort. Again, you can see, you can find the limit. Limit z approaches 0, e raised to power 1 over z. So clearly say, if you taken as a limit, z approaches 0 negative of 1 over z. So that will give you e raised to power minus infinity, that is 0. But if you take the limit as z approaches 0 positive, then it will be 1 over 0 is infinity. So clearly say you have the two different limits. That means limit does not exist. Once the limit does not exist, that means we call as the essential singularity. Fine. So pole, because the limit is not infinity, removable, this option is cancelled. Make sure if you substitute this limit e raised to power 1 over 0, e raised to power infinity is infinity, then you may think about that it's a pole, but that is not true. This is the first method. Second method is how you can solve that. Again, because of the exponential part, I can simply choose f is my 1 over z. Clearly say the pole is occurring at z is equal to 0. So once we can say z is equal to 0 is my pole, then e raised to power 1 over z is my essential singularity at z is equal to 0. So again you can get as singularity essential. So right answer is A is my correct answer. Don't forget to like and comment on my video. You can share this video with your friends as well. Consider the function this. Firstly, 0 pole 0 this. Can you find the limit at z is equal to 0? Firstly, it is pi cos of pi into z divided by z square sine of pi z. So when substitute z is 0, cos 0 is 1, it is 1 over 0, that is infinity. Once this is infinity, that means we call as the pole. Fine. So that's it, either the pole of this or fine. Now, as z approaches 0, fine, we all know sine of x is approximately equal to the x. Fine. Then my function, this is a shortcut quick. You can solve like this manner. It's a pi cos of pi z divided by this number is my pi z. So it's a pi z cube. So pi and pi will be cancelled out. Cos pi z over z cube. Now clearly say this value is finite at the point z is equal to 0. So that means this function has a pole of order 3. Fine. So it's a pole of order 3. This function is cancelled. Now, another way how you can check about the pole, if I consider this is my q, denominator is my q. Fine. It is z cube. Now, what is the order? How you can check about the order? I can find the derivative and compute the values at z is equal to 0. This value is my 0. It's a 3z square, again 0. You have to find until it becomes a non-zero. 6z, again 0. And the third derivative is my 6, which is non-zero. So that means the third derivative is my non-zero. So that means order is my 3. Since we are solving the denominator, that means it's a pole of order 3. This is the second method. One more method. Third method is whenever you have the function raised to power n, whatever the n, fine, always find the zeros of this part. If I say the order of this component is my alpha, then the order of this will be alpha into n. So look at that, it is a z cube. Fine. What is the order of this z? 1. Fine, because it's a z is equal to 0 is the one root. Because if you take q is my single z, q dash is my 1, which is my non-zero. So therefore it's a 1, so 1 into 3, that is alpha into n, 3 order. Now is the only simple pole. Is the only n is equal to 1, 2, 3 are the only simple pole. That's wrong, because z is equal to 0 is also the pole. How you can find the residue? So again, you can see, let me clear this one. Now you will obtain this expression. What is your my f is? Pi will be cancelled out, cos pi z over z cube. Now your target, this is the pole of order 3. So how you can find the residue? How you can find the residues? 1 over 3 minus 1 factorial. Fine. Second derivative of remaining quantity, that is a cos of pi into z. If it is of the third order, then you have to find the second derivative. Then what is the second derivative of this? Minus pi sine of pi z. This is the first derivative. Then it's a 1 over 2. 1 over 2 is the second derivative, will be minus pi square cos pi z. Compute the values at the point 0. Cos 0 is 1. The answer is minus pi square over 2. But it's a pi square over 3. So right answer is C is my correct answer. If the value is not defined at z is equal to a, that means the function is my this case, but limit z approaches a of fz is existence. What does it means? If the limit is existence, we call as removable singularity. Fine. So then it's a removable singularity, essential, and none of these are my answer. I Throughout the video I will always use this concept. Limit existence removable, limit infinity we call as a pole. If limit does not exist, we call as the essential singularity. You can also solve any kind of this singularity problem with my this concept. Now again you can pole essential. Firstly we can find the limit at infinity. Limit z approaches infinity, z is to power 4 sine of 1 plus. So you can see that it's a z is infinity, 1 over infinity 0. It's a z raised to power 4 into 0. That means infinity raised to power 4 into 0. Right? That is indeterminate form. So what you can do is, first of all, this limit is my not finite, or but we can't say that it's not a finite. I can change this function into 1 over z. So this will be 1 over z raised to power 4 sine of z over z plus 1. Now instead of the infinity, we need to calculate the value at z is equal to 0. Now we all know at the point z is equal to 0, sine of z is approximately equal to z. So this quantity will be my z plus 1 over z raised to power 4. I can say it's a z cube z plus 1. So what is the pole? Because it's a denominator. So pole is minus 1. Pole is my 0. What is the order of this? Because the power is 1. What is the pole of this? Or power is 3. So the order is my 3. Right? So pole of order 3, pole of order 4 cancel. Now once it's a pole, it can never be removable. It can never be essential. Make sure singularity is either the pole, either the removable or the essential. So the right answer of this problem is B is my correct answer of this problem. The function f of z is z raised to power m at z is equal to infinity. Now, what is the value of z? Z is not given, m is not given to you. I can choose m is my 1. Then this number will be z into e raised to power. Sorry, it will be my z. Fine. Now, firstly, we can check about the limit at z is equal to infinity. So, z into e raised to power z, it will be infinity. Now, infinity into e raised to power infinity. But we can't say. So you can see about 1 over z. So it is e raised to power 1 over z over z. Because you can't say about that because this is my essential singularity. Fine. Now you can see about this. What does it means? Non-isolated. Firstly, you can check about the. This is now at the point z is equal to 0. Now you can check about that. First of all, if you can see that this is 1 over z. If you expand the series of the 1 over z, exponential term 1 plus 1 over z square and so on. How many terms of the negative power of the z? They have the infinite terms, fine, infinite terms of the 1 over z. So that means, what does it mean? That means it is my essential singularity. So what is that? Now you have the two essential singularity. It means it is not a pole. Fine. Once it is not a pole, then you can cancel out this. Now, how you can check about the isolated or non-isolated? Isolated means you can find the limit point of the zeros. Fine. Non-isolated means you have to find the limit points of the poles. Fine. Now, firstly, I can see this is my function. E raised to power 1 over z is 0. What will happen? Can you find this quantity? When it will be 0. E raised to power 0 will be, it is not possible. Now you are unable to find. Now what is the definition of the isolated and non-isolated? You can see z is equal to infinity is my essential singularity. Now once it's a infinity, you can see the only singularity of this function is z is equal to infinity. Since it is my singleton only, so that means this is my isolated. It can never be non-isolated. If it is more than one essential singularities, then only you can say it is a non-isolated, otherwise not. The function f of z, which is 1 over e raised to power z minus 1, is entire. Entire means there is no pole, but clearly say e raised to power z is equal to 1 is my pole. When the value of the z will be 1, it is my 2 and pi iota. 1 means that is my cos of 2 and pi plus iota sine 2 and pi will be my 1. Fine. So that means you have this number of the poles. So once you have the pole, it can never be entire function. Now, removable singularity. Now you have to find the limit at z approaches 2 and pi iota of this function. Now, if it is a unique and existence, then only you can say this is my removable. So if you substitute e raised to power z is 1, 1 minus 1 is 0, it is infinity. Once this is infinity, that means it is not a removable singularity. Once it's an infinity, that means it is my pole. Fine. Now it's a pole. Can you find the residue? So how you can find the residue? That means limit z approaches 2 and pi iota. Okay, if you have the function fz over gz and gz is my simple pole. In this case also you can see this is single pole. Then you can find the residue as f divided by its derivative directly, or you can find, because we need to find at the value of 2 and pi iota into fz over gz. That's on your choice. Fine. But since it is a single simple pole, then I always prefer to use this value. Now, what is the f is my this? First of all, f over g. That means this is the numerator and denominator. What is the value of this? Z over 2 and pi iota. F is my 1. This is my f. This is my g. 1 over e raised to power z. So if you substitute 2 and pi iota, it is my 1. That is, so that's a residue is 1. Correct. Now, since we have obtained limit of 2 and pi, now it's a z0. What is the value of the z0? Limit z approaches 0 of fz. What is the value? 1 over 0 is a infinity. Essential means limit does not exist. So that's a wrong answer. That is also the pole. But it is essential. That's a wrong. C is my right answer of this problem. Okay, now it's a essential singularity countable of this. Now clearly say e raised to power. If you look about the pole, that is only for the denominator. That means z is my plus minus iota. But if you look about this, I can found the singularity of the tan of z. Fine. What is the singularity of the tan of z? I can substitute this as a 0. That means z will be my n pi. Fine. Now I will check whether this is my pole, whether this is my removable or is essential. I will check about z approaches n pi of fz. Fine. So what is the value of this? Z approaches n pi. This is the numerator. That means we are talking about the zeros. Fine. So once you can talking about the zeros, can you limit point of this? What is the limit point of the zero as n approaches infinity? That is infinity. Fine. So therefore, limit point of the zero, that means we call as the isolated essential singularity. Fine. Once z is equal to z naught is the essential singularity, then e raised to power tan of z is also has my essential singularity. Now it is my for all n belongs to the z. So what is a z? Is a countable, uncountable is cancelled. Only singularities are my simple pole, but they are not pole, they are my essential singularities. So the right option is only my A is the correct answer. Now it's a gate 20 again, z is equal to 0. We will firstly find the limit and then we will see what will be the result. So if you substitute 0 is a 0 by 0 form, then I can apply the L'Hopital rule. It's a minus minus plus over 1. When you substitute 0, it is my 1, which is unique and exists. Once it is a unique and existence, that means this is called as removable singularities. So pole is cancel out, essential cancel out, only right option is removable singularity is my correct answer of this problem. The function z is equal to 0. Again, we can take about this z minus sin z over z cube. Fine. You can't say directly that z cube is a pole. Firstly, we will see whether it's a pole or not. So clearly say it's a 0 by 0 form. I can apply the L'Hopital rule. 1 minus cos z over 3z square. Again, you can see when you substitute 0, again it's a 0 by 0 form. If you again define that, it's a 1 over 6z. Again 0 by 0 form, cos z over 6. As limit z approaches 0 is a 1 over 6. 1 over 6 is my unique and finite. That means we call as the removable singularity. Essential, pole, all are my cancel. Again, at the point z is equal to 0, so limit z approaches at the point z is infinity. E raised to power z over 1 minus. So again, it's infinity by infinity. I can apply the L'Hopital rule. This is e raised to power z. which comes to be -1, which is my unique and finite. So once is a unique and finite, we call as the removable singularity. So removable is fine, pole is cancelled. Now you can see they are not talking about the essential or something. Fine. So we will check about the isolated or non-isolated. So how you can do that? I will check about the pole. Fine. Can you find the zeros of this? What is the zeros of this? E raised to power z is a -1. So when cos value will be negative, when it will be the 2 and odd numbers of the pi. Fine. So z will be my 2n plus 1 of pi iota. Now clearly say, because I need a z infinity. So as n approaches infinity, z approaches infinity. Now since we are talking this number as a pole, so what is the limit point of the pole? Limit point of the pole will map to the non-isolated singularity. So that's a non-isolated singularity. Is isolated cancel. B and D are my correct answer of this problem. The simple pole. First of all, pole, that means z -1 square, z plus 2. Now clearly say the power is 2. That means it has -1 is my pole of order 2. This z is equal to -2 is a pole of order 1. So 1 means there is a single simple. So z is equal to -2 is my simple pole of this answer. Don't forget to like and comment on my video to support my efforts. F of z is my sine hyperbolic z. So what is the formula for the sine hyperbolic z? So that is e raised to power z minus e raised to power minus z over 2. So I can write this number is 1 over. So that will be 2 over e raised to power z minus e raised to power minus z. Number of the singularities. So I can found the pole. Fine. E raised to power z, which is equal to e raised to power minus z. E raised to power 2z is equal to 1. So when it will be 1, cos 1 will be my, that's an even number, 2 and pi iota. So that means z will be my n pi iota. Fine. Then the number of the singularities of this. That means we are talking about the order. So if I consider h is my this number, fine. Clearly say h of 2 n pi iota will be 0. What is the h dash? E raised to power z plus e raised to power minus z. What is the value of the n pi iota? This will be my non-zero because of this positive sign. It's a non-zero, that means order will be my 1. So the right answer of this problem is D is the right answer of this problem. For the function z is equal to 0. Now you can see this is, there is no denominator. Denominator is my 1. So we are talking about the zeros. Fine. When it will be, so that means 1 over cos 1 over z. It is my n pi. This is my 0. What is the 0 of this sine? This is my zeros. Sine 0 will be my n pi. So can you find the values of cos 1 over z is 1 over n pi? Fine. So once it will be this number, as n approaches infinity, this number will be 0. This number will be 0 as n approaches infinity. So again you can see, also you can see cos 1 over z will be 0. What is the value of the z? 1 over z will be my cos 0 will be 2n plus 1 pi over 2. So that means z will be my 2 over 2n plus 1 pi. But there is no need, I think. We are talking about this. I can simply start with the limit. What is the limit? Z approaches 0 of f of z. Firstly, we will check always by this manner. So that will be sine 1 over cos infinity. Cos infinity means that is a number lies between -1 to 1. So that means the limit does not exist. So once the limit does not exist, that is always be then essential singularity. Pole, this option cancel because it's not a non-isolated. Once we get as essential singularity. So the right answer is C is my correct answer of this problem. The example of the non-isolated essential singularity. Remember, non-isolated means you have to find the limit points of the poles. Fine. Limit point of the pole. That means the denominator. You can see about that. There is no essential. What is the definition of the essential is? You have infinite number of the terms which involve 1 over z minus z0. But if you expand this series, it will be 1 plus z plus z square upon 2 factorial and so on. So clearly say there is no term which involve 1 over z minus 2. So that means this is not essential. So once it is not essential, it is not a non-isolated. Similarly, look about that. At the z is equal to 2. We will check about the limit firstly. Firstly, I will check about this sign term. What is the sign of 1 over z minus 2? This will be 0. Sign of infinity does not exist. That means this is essential. Fine. Now look at the tan of z minus 2 over z. If you again look about the limit, firstly we will check about whether it's essential or not. As the limit z approaches 2, tan of z minus 2 over z. So that will give you the tan of 0. That is a 0. That is a finite term. Once it's a finite, we will call as the removable singularity. But we need a essential singularity. Look at the first option. What is the limit at z is equal to 2? That will be tan of infinity. That is not a defined. So this is the essential singularity. Now you have the two options, either A or B. Now, how you can find the non-isolated? So from this we obtained that this is my essential singularity. This is my essential singularity. Now we need a non-isolated. That means we need to find the limit point of the pole. But you can see from the second point there is no denominator component. This is my 1. If you substitute this as a 0, this will give you the limit points of the zeros. Once you will get the limit point of the 0, you will get as the isolated essential singularity. So this option is also cancelled. Only left option left is my A is the correct answer. You can remember that limit point of the pole is always give you the non-isolated singularities. Pole means denominator 0. Limit point of the 0 means isolated singularity. But if you want to check how you can do that, I can see, I can write this form P over Q. Fine. Now, what is the limit point of the pole? I can substitute denominator as a 0. Cos value will be 0 only when it's a 2n plus 1 pi over 2. So can you find the value of the z? Z will be 2 plus 2 over 2n minus 1 pi. So what is the value as n approaches infinity? As n approaches infinity, this will be 0. It goes to my 2. So yes, A is my non-isolated essential singularity. Remember, first your target is to find the essential. How you can find the essential? Check the limit, and it must be does not exist. In this case, you can see also the third part. If you take the limit of this quantity, it will be my 1, which is a unique. That means it is my removable, but we need a essential singularity. Look at this another one. Again, you target is about the z is equal to 0. Firstly, we will check about the limit z approaches 0. So that will give you the sign of infinity. That means limit does not exist. Fine. If limit does not exist, that means we will get as the essential singular. Removable, not, because limit is not finite. Simple pole, not, because limit is not infinity. Essential singularity is my right answer of this problem. Let f is my meromorphic function given by f is z over 1 minus e raised to power z of sine z. Z is equal to 0 is the pole of order 2. Firstly, we will check whether it's a pole or not. What is the limit at z is equal to 0? It is z over. Again, I can use the same concept. When z approaches 0, sine of z will approaches toward the z. So this is my z. So this value will be cancelled out. When z is 0, it will be infinity. That is a pole. Fine. Now, how you can check about the order? Because my denominator is z minus z into e raised to power z. Now, what is the meaning of the order 2? That means q of z is also 0. Q double dash z is my non-zero. Then only it's a pole of order 2. So what is the derivative? 1. It will be z into e raised to power z minus e raised to power z. It will be minus z e raised to power z minus e raised to power z. Now at the point z is equal to 0, this value will be 0, this value will be 0, this value will be minus of 2, which is non-zero. So the second derivative is non-zero. That means the pole of order 2 is my correct answer. Now look at the second one is z is equal to 2 pi iota is a simple pole. Now since this result we can never use because it is not a 0, then it's a simple pole. I can take it as a denominator part. This is my sine of z. I can open this bracket. It's a sine z minus Ez of sine z. What is the meaning of this simple pole is? That means q dash will be my non-zero at the point this. So can you find the q dash? It's a cos of z. It will be Ez cos z plus Ez of sine z. Now at the point z is equal to 2 pi iota. This value will be 0 because k is my integer, sine of 2 pi 0. This is my 0. Cos of this value will be my 1. Whatever the value of this value will be my e raised to power 2 pi iota 1. Cos of 2 pi iota will be 1 minus e raised to power 1. This is 0. So clearly say it will be my 0. So that means it's a simple pole, option yes. Fine, because we will get as the double pole. First derivative is my non-zero, so that means it is not my simple. Look at that z is equal to ky. Now you can check about the ky. Let me again k so again q I can take as a sine z minus e raised to power z sine z. Of all those apart from the q 0. It's a cos minus e raised to power z sine z minus e raised to power z cos z. So what is the value of this at the point k pi, where k is my integer? Sin k pi 0, sin k pi 0. Cos k pi is a minus 1 raised to power k, e raised to power k pi. Find sin of k pi 0, e raised to power k pi, and sin cos is my minus 1 raised to power k, which is my non-zero. So yes, it is my of simple pole. Right? Also, you can check whether it's a pole or not. You can see limit z approaches k pi of this function. So it's a k pi is a finite. It's a finite. Sin k pi will be 0. So that goes to infinity. That means it's my pole, and the order is my 1. Fine. Now look at that. Z plus 2 pi iota is a pole or not. Now you can see whether it's a pole or not. We will check about the limit firstly. Z approaches pi plus 2 pi iota. If you substitute this value in this given function, it's a pi 2 pi iota. It's a 1 minus e raised to power pi, e raised to power 2 pi iota. Sine, what is the value of this sine? Pi plus theta. It is my minus sine theta. It's a negative sine of 2 pi iota. Clearly say this value will be 1. It is my non-infinity. So once it's a not infinity, that means it is not a pole. So the right answers are A and B are my right answer of this problem. Let me quickly check whether it's a simple pole or not, because if it is a k pi, I have obtained this derivative. let me quickly check at the 2 pi iota. 2 pi iota k. Sine 2 pi iota is integer, 0 is a 0. Cos 2 pi iota is a iota also. Just wait. This is my cos. It's not a 2 pi, it's a 2 pi k iota also. E raised to power 2 pi iota is 1. Sine of 2 pi k iota minus e raised to power is a 1 and cos of 2 pi. So this value will be cancelled out. What is the sign of 2 pi iota? Is a non-zero because of iota. If it is only 2 pi k, then it's a 0. So that's a non-zero. So once it's a non-zero, that means yes, it's a simple pole as well. So the right answer is this is my correct option. Fine. This value will be 0 because this value will be my 1. So sine minus sine is 0. This is non-zero. Yes, it's a simple pole. A, B, C are my correct answer of this problem. Look at this another one. The function fz is defined like f is integration from 1 to 2 1 over x minus z whole square into dz. There is a meromorphic function that agree with the this is agree with the fz. So now what does it mean? By the identity theorem, both have the same value. Can you integrate them? Integration with respect to x. So that will be minus 1 over x minus z. Fine. Now if you substitute this upper limit, it's a 2 minus z plus 1 minus z. Fine. Or I can say it's a z minus 2 minus z minus 1. 1 and infinity are the pole. Now this is my f and g coincide. Now how you can check about the infinity pole? Clearly say when you take limit as z approaches infinity, what is the value? 0, which is finite. But for the pole, we need an infinity. That means infinity is my removable singularity. So this option cancel, this option cancel. Fine. Once you take as a limit z is 1 and 2. Once you take the limit 1, it goes to the infinity. Fine. 1 over 0 is infinity. So 1 is my pole. Fine. Once you take 2, again the limit will goes to the 0. Yes, it is my pole. Fine. And again you can see the powers are my 1. So the order is also 1. 1 is my simple pole. C and D are my correct answer of this problem. Don't forget to like and comment on my video to support my efforts. F of z is 1 over e raised to power z minus 1. Then is a meromorphic. Meromorphic means that is the function is entire except at the poles. Fine. Remember, this condition is defined, is given to define the function. Like we can say 1 over is my 1 over z, where z is non-zero. Fine. This it doesn't mean that e of z can never be equal to 1. This condition is only implied to well define the function. What is the pole? Can you define the pole? E raised to power z is 1. So that means z will be 2 n pi iota. Fine. So these are my pole. Fine. Outside this pole, it is my entire function. So yes, this is my meromorphic function. The only singularities of the f are my pole. So let me check whether they are pole or not. We will check the limit at 2 and pi iota of fz. So since the numerator is finite, this is my 1 minus 1, 0. That is infinity. Once this is infinity, we can say it is my pole. The only singularity is my pole, correct option. There are infinitely many poles on the imaginary axis. You can see my answer of the pole is 2 pi 2 n pi iota, where n is my integer. Clearly say because of this n is my integer, it has infinitely many values. And it lies on the imaginary axis. Yes, you can see the real component is 0, imaginary component is 2 n pi iota. If you like the graphically, this is the point of 0, comma 2 n pi iota. So it all lies on the imaginary axis. Each pole of the f is my simple. How you can check about the simple? The first way is because the power is 1, but because this is not a polynomial, I can choose denominator 1. Simple pole means this value must be my non-zero. Then only the order is 1. What is the derivative is? Now clearly say at the point z is 2 and pi iota. This value will goes to the 0, 1 minus 1. But this value will goes to the 1, which is non-zero. That means it is my order 1. So order 1 means that's a simple pole. So the right answer of this problem is A, B, C, D are my correct answer. Look at the next one. At the point z is equal to 0 is a removable pole essential. So firstly we can find the limit exponential z over 1 minus cos z. So that means exponential, it is 0 by 0 form, cos 0 is 1. So I can apply the differentiation, this into, or otherwise it's a 0 by 4. Otherwise what I can do, I can find the pole of this. Fine. If I got the pole as z0, then I can apply the rule for the exponential. So I can choose the g of this quantity. Fine. Now, what is the limit as z approaches 0 of g? It is my 0 by 0 form. I can apply the L'Hopital rule. It is 1 over sine z. So as z approaches infinity, sine 0, infinity. That means 4. So z is equal to z0 is the pole of g of z. So what does the meaning of this case? This is my essential singularity. Fine. So that means this is my essential singularity. Pole is cancelled. Fine. Clear? Now, Lorentz series. Once is essential singularity, you can expand in the Lorentz series with the infinite terms of the negative powers. Fine. So once is an infinite terms of the positive and negative power. So the right answer is C and D are my correct answer. Always remember my simple tips that you have to find just the limit, and make sure for the limit you have to watch my this part PY question of the limit. Now f is my entire function and limit z approaches infinity, f of z is my infinity. What does it means? That means it's a pole. That means z is equal to infinity is my pole. Fine, because it's a infinity, but this is not at z is equal to infinity. So that means z is equal to infinity is the pole of f of z. I can change into the 0. That means z is equal to 0 is the pole of f of 1 over z. So f of 1 over z is a pole at the point 0. 1 over z is the essential singularity. Cancel. Now, what is the another shortcut tricks? As I mentioned you, once the function is my entire, fine, plus limit as z approaches z naught of fz is, if it is infinity, if and only if this is my polynomial, if it is my finite, if and only if the function is my constant, and if the limit does not exist, if and only if the function is my transcendental. You can see about my this shortcut tricks. The function is entire, function is at point infinity, then it's a polynomial, otherwise finite is a constant, otherwise transcendental. Now you can see that means the function fz is my polynomial. Fine. So f cannot be polynomial, cancel. Once is a polynomial, how many zeros are there? Finite zeros always. Any polynomial you can choose, say 1 plus z. So clearly say it is my finite number of the zeros. Make sure you have to remember my shortcut tricks. It's a very simple tricks are there. I have used only the one method. This is the first method. There is one more method. There is one more method. Second method is, can you think about any of the function which will satisfy this property? You can see f of z is z. This is my entire function. Fine. Also limit is infinity. So again, f can't be the polynomial. Cancel out. Now 1 over z. is 1 over z. Clearly say this is my pole of order 1 at 0. Why pole? If you calculate the limit at z approaches 0 of 1 over z, it's an infinity. So infinity means pole. This option is the correct or this option is the cancel. Once is a polynomial, definitely it has the infinitely many zeros. So C and D are the correct answer. Look at this another one. Again, removable pole essential of this. We can found the limit z approaches 0 of fz. When you take 0, it's a e raised power 0 1, e raised power 0, that is infinity. Once it's a infinity, that is a pole. So that is pole is the right answer. Fine. So removable because it is not infinity, it does not exist, not possible. So this is my. Now how you can find the residue? Residue at z is equal to 0. What is the pole? This function. So that means you have to find limit z approaches 0, z minus 0 into f, this plus 1 over ez minus 1, or because z is equal, firstly we can check about the order. So if I choose about the denominator, this is h. What is the h dash? E raised to power z. Clearly say h of 0 is my 0, h dash of 0 is my non-zero. That means z is equal to 0 is my simple pole. Fine. So once it's a simple pole, then instead of writing this quantity, how you can write that? You can write the numerator divided by the derivative of this denominator. Fine. Now at the z is equal to 0, 1 plus 1 over 1, that is 2 is my right answer of this problem. B and D are my right answer. You can also solve the same way. This is the 0 by 0 form. You can apply the L'Hopital rule. Again, you will get the two answers. But once it's a simple pole, then if your function is pz over qz, then you can find the residue as pz divided by q dash of z at the given. If f is a meromorphic function, f and g are the meromorphic function. If f has a 0, f has a 0 of order k. Fine, this is the meaning of this. G has a pole of order m at the, this is the meaning of this z minus 0. Then what is the g of fz? If you substitute this value, this is z minus a power km. Now clearly say this is my pole. What is the, if I just simply consider z minus a, what is the order of this pole? Order is my 1 because if you consider as h, h dash is my 1 which is non-zero. So this quantity has a pole of order 1. The power is km. So the pole is my order km. So this is my order, pole having order km at the point z is equal to a. And you can see it's all about the CSIR NET examination. You can solve in a couple of seconds. Don't forget to like, share and comment on my video. Okay, there are the two methods to solve. First method, by the definition, z is equal to 0. I can choose the values of the m and n. Firstly, I can choose m is 1, n is my 1. Fine. Which case will satisfy? This case, 1 is less than of the 2. Fine. 1 is greater than 2 not. So that's a pole. We will see what is my fz. It is sin z over 1 minus cos z. Now check whether z is equal to 0 is a pole or not. It's a 0 by 0 form. I can apply the L'Hopital rule. It's a plus sine of z, which is infinity because it's a 1 over infinity. Infinity means pole. So whenever m is less than of 2n, it is my pole. Look at the second case. If I choose n, m is 2, n is my 1. Clearly say equality satisfied. Then what is my fz? Sine square z over 1 minus cos z. Then check about the limit z approaches 0. Again, it's a 0 by 0 form. I can apply the L'Hopital rule. It's a 2 sine z into cos z over sine z. So clearly say which is my 2, that is finite number. Once is a finite number, that means it is my removable singularity. So it is not a 4. Fine. Now that means this case is when n is greater than, this is m is equal to n. Fine. Now the third case I will consider when m is less than of n. So I can choose m is 1, n is 2. Fine. Then what is my fz? This is my sine of z over 1 minus cos z square. Then let me clear this screen. Then I can find the limit again. Limit z approaches 0. Again it's a 0 by 0 form. I can apply the L'Hopital rule. It's a twice 1 minus cos z into sine z. So clearly say it's a cos 0 is 1. It is a 0, so it will go to the infinity. That is my 4. Fine. So again you can see I have taken m is 1, n is 2. Again this case satisfied. So therefore whenever m is greater than n, whether m is less than n or m is equal to n. So in all the three cases we have obtained either as a pole or either has a removable singularity, but we never get as the essential singularity. So the right answer is A and B are my correct answer. This is the first method. Second method is you can find the zeros of this numerator. If I choose the numerator is my, this is my numerator, q of z is my denominator. Fine. So can you find the zeros of this p and q? Fine. Forget about the m. So if I simply take p is my sine z, what is my p dash is cos z. At the point z is equal to 0, clearly say this number is 0, this is my non-zero. That means what is the order of p is 1. So this power m, so that means order of p is, I have obtained 1 raised to power. So 1 into m is m. Fine. Similarly, I can think about the cos z. If I simply take this is q, q dash will be my sine z. This value will go to the 0 as z approaches 0. This is also 0. Q double dash is cos z, which is non-zero. That means order is my 2. That means the order of q is my 2 into power. Power is my n. Power is n. So that means 2n. Fine. Now what is the, now your target is to find the z is equal to 0. So what is my shortcut tricks? If m, what is the m is? M is the zeros of this numerator. So you can see, let me clear this. So what is the order of the p raised power is m. What is the order of this is 2n. Now whenever m is less than of the n, then it's a pole. That means whenever m is less than of the 2n, we call as a pole. And whenever m is greater than equal to n, that is m is greater than equal to 2n, we will call as the removable singularity. Fine. These are the shortcut tricks I have given. So you can see m is greater than equal to 2n, removable, pole, rest options are cancelled. A and B are my correct option. But make sure if you forget to remember these shortcut tricks, then again my usual method is take the limit, check whether it's infinity, finite or does not exist. Don't forget to like, comment and share on my videos. Okay, then a function is given to you, many zeros. Firstly, we can check about the zero. F of z is 0. That means exponential is my 1. When the complex number will be 1, when it's at 2 and pi iota. That means 1 over z plus iota will be 2 and pi iota. So that means z will be 1 over 2 and pi iota minus iota for all n in my z. clearly say it has infinitely many values, but he said finite values. That's a wrong answer. The sequence of the zeros converges. So can you find the limit point? The limit point will converges to minus iota, and we all knows this is the zeros. Limit point of the zeros will converges to the isolated essential singularities. So that means essential singularity converges to the pole, converges to the removable. That's a wrong, that's wrong, that's only correct option of this. Limit point of the zeros will always converges to the essential singularities or particularly isolated singularity. Okay, look at this another one. Which of the following statements are my true? The function is given as a tangent. I can return this function is sin z over cos z. Which of the following is the entire function? Entire means there is no pole, but that's a wrong because the function has a pole when cos z is 0. That means z is my 2n plus 1 pi over 2. These are my poles. Fine. The first option is cancelled. Second option is meromorphic function. Yes, because apart from this, sin z is my entire function. Tan of z is isolated singularity, non-isolated singularity. Now you can check about the, now you can see they are not talking about the pole, removable or essential. What is the meaning of the isolated? That means if you consider any of these singularity, z not, fine. If you consider this circle, then no other singularity involved. No other singularity involved in this circle. But you can see when you take z is infinity, what does it mean? Z minus infinity, whatever the delta you can consider, your interval will be my this. There is no other singularity involved in this case. Or moreover, once you can talk about the isolated, or once you can take about the non-isolated, but come in your mind, that is always about the limit point. Fine. So now if I take this is the limit point of the pole. What is the limit point of the pole? Limit point of the pole is approaches to infinity as n approaches infinity. So once the limit point of the pole will converge to the non-isolated essential singularity or non-isolated singularity is the right answer. B and D are my correct answer of this problem. Okay. Remember, z is equal to infinity is not an because limit point 0 is not the singularity, infinity is not the singularity of this sign here. Consider the function which are the following pole, all even. So how you can check about the pole? Firstly, I can take the denominator as a 0, but before that I can make on the parallel line. It's a z by 2. I can also write the denominator in terms of z by 2. Fine. So that will be 1 over 2 cos pi z over 2. Now, how you can find the poles? The pole means the denominator part you can put them as a 0. So cos 0 will be my only. When the cos 0 will be 0, that is 2n plus 1 pi over 2. So pi over 2 will be cancelled. So z will be my 2n plus 1. That is my odd number for all n in the z. It's all integer cancel, even cancel, odd is the right answer. All the integer of the form 4n plus 4k plus 1. Clearly say 2n plus 1. Fine. So now all those integer, odd integer also lies in this case. Yes, it is also of the form this one. So that is C and D are my right answer of this form. That f of z is my this function is entire, function is not entire because you can see these are my poles. Fine. So that means the pole is my 2 and pi iota. So once you obtain the pole, it is not an entire. The only singularities are my pole. We can check about the limit 2 and pi iota. If we conclude as infinity, then it is a 4 e raised to power z. So what is the answer? If you substitute numerator is a 1 and 1 minus 1 is a 0. Yes, it is my 4. Fine. It has infinitely many poles. Yes, because you can see it is n approaches to, and because of this n is my integers, it has infinitely many poles. Is it lies on the imaginary axis? Yes, again, because z is my 2 and pi iota. It is a purely imaginary number. Each pole is simple. How you can, as a simple, I can substitute the denominator as a h. Then I can found the h dash. Clearly say this number will goes to the 0 at the point 2 and pi iota. Fine, because e raised to power 2 and pi iota is 1. This goes to the 1 which is non-zero. So the first derivative is non-zero. That means order is 1. So once the order is 1, that means it's a simple B, C and D are my right answer of this problem. F of z, then isolated singularity z0. Firstly, we can check about the limit z approaches 1. Removable if goes as a finite. Once is a 1, is a 1 minus 1 0. E raised to power 2 pi iota 1 minus a 0 by 0 form. I can apply the L'Hopital rule. Fine. So it's a e raised to power 2 pi iota into z into minus 2 pi iota over z square minus 0. Then I can substitute the value of the z is 1, e raised to power is a 1. It is my minus 2 pi iota, which is my finite number. Once this is a finite number, yes, it is my removable singularity. Isolate singularity, infinitely many pole, each pole of order 1. So firstly, we can check about the z is equal to 0. Fine. Or isolated. How you can check about the isolated? We can find the limit point of the zeros. Fine. At z is equal to 0. So firstly, we will see how we can say about that. If, okay, firstly, because the zeros has only the z minus 1, it has no limit point. So if I simply find the limit point of the pole, that means e raised to power 2 pi iota over z is equal to 1. That means 2 pi iota over z is, I will think about this part firstly. 2 n pi iota. 2 pi will be cancelled, pi will be cancelled, it is 1 over n, where n is my integer. So because n is my integer, it has infinitely many values. Yes, third option is also correct. Now, what about the other one? Now each pole, this is my pole. Now we will see each pole is of order 1. If I choose the h is my denominator part. Fine. What is the h dash? E raised to power 2 pi iota into z minus 2 pi iota over z. Now clearly say whenever z is 1 over n, e raised to power 2 n pi iota is 1, 1 minus n 0. This component, this value will be 1, this value will be my minus 2 pi n iota, which is non-zero. So at first derivative is my non-zero, that means order is 1. So each pole is of order 1 is the right answer. Now, whether it's isolated, now you can see at z is equal to 0. Can you find the limit point? So limit point of the pole is when n approaches 0, it goes to the 0. Fine. So that means we obtained this part, but the limit point of the pole will always give you the non-isolated singularity. But he said isolated singularity. That option is cancelled. So B, C and D are my correct answer of this problem. Okay, so recent year, again you can see it's a recent year paper. I solved the same way. The function is 1 over z minus z square. Fine. Function is entire. Clearly say it is not entire because you can find the pole. I can easily find the pole of this function. Fine. This is my minus b plus minus b square minus 4ac over 2. These are my poles. So once is a pole, it is not an integer. Now clearly say it has a 2 and 1 is my positive, fine, and second is my negative. So both are my distinct. Yes, it is my simple pole. No, simple pole at z is equal to 0. Sorry, not at this point. How you can check about the pole? I will found the limit. Z approaches 0. So this will go to 1 over 1, which is finite. So finite means removable singularity, not the pole. Fine. If it is a pole, then it must be infinity. Now, look at the third and fourth case. They are talking about the Taylor series. Taylor series of an z raised to power n. So that means center is my 0. Fine, because I can write this value as z minus 0 raised to power n. Then your target is to find the a1, a and so on. This is the case. Fine. Now firstly a0. A0 will be function value at the point 0 over 0 factorial. What is the function value? Is 1. 1 over 1 is 1. A0 1, A0 1. A1, first derivative of this, minus 1 over 1 minus z square into minus 1 minus 2z. Fine. Over 1 factorial at the point z is equal to 0. What is the value at the point z is equal to 0? It is 1 over 1. So a1 is 0 is the wrong answer. Only left option is a is my, sorry, d is my correct answer, because you can see this is the false. It's a December 2023. Again, I will solve the similar manner. It's a meromorphic function. F has no 0 and no pole. NP and the NP and the NC are the number of the poles and the number of the zeros of F. Then, okay, remember always what come in your mind when you think about this quantity F dash over F. That is my argument principle. N minus P. What is the N is? Number of the poles. Sorry, number of the zeros, and P is my number of the poles. Number of the zeros and P is my number of the poles of F, this quantity. Now in this case, if I choose H is my Z into F, then your target is to find this value. Fine. Again, this will be my N minus P. The only difference is you have to find the number of the zeros of H. P is my number of the poles of H. Now how you can find that? Now clearly say if H is my multiply by Z, so number of the poles are same, because pole is always related to the denominator. The denominator is still 1. So the number of the poles is still NP. What is the number of the zeros? Because I have multiplied with the Z. So Z power 1. So that means if the previous one is NC, N0. N0 is my number of the zeros plus 1. Now you can substitute the answer. It will be N0 plus 1 minus NP is the right answer of this problem. A is my correct answer. Now look at this another one. It's again June. Which of the following has the zeros? What is the function is z square 1 minus cos z. Now, because it's a product sign, I can find the zeros of this separately. I can find the zeros of this separately. That will be the easier one. Fine. I can choose the h1 and h2 are the two functions. The zeros at the point 0. So it is my 2z. H2 dash is my 2, which is non-zero. That means this value will goes to the 0 at the point 0. This value also goes to the 0. It is not 0. That means order is my 2. In this case, this is my sin z. This will goes to the 0. This will goes to the 0. H2 double dash is cos z, which is not goes to the 0. So again, the order is my 2 corresponding to the point 0. So since it is a multiply, so the total order is my 4. But he said order 2, cancel. Order 4, right. Otherwise, you can also think about that f dash, f double dash, f triple dash, f4 dash, f5, and that will take a very lengthy calculation. So that's why I've taken as a 2 separate. Now, add the point 2 and pi. So now, again, I will check, again, I already take the derivatives. Now, I will check about there, add the point 2 and pi. This value at the 2 and pi is my non-zero. So it means there is no order. Order is 0. Fine. At the point of the 2 and pi, cos 2 and pi is 1. 1 minus 1, 0. Cos 2 and pi, 0. This value will go to the 1, which is non-zero. So order will be 2. This has a 0. This has a 2. So total order is my 2. This is 1 wrong. C and D are my right answer. Which of the following functions are the entire and then have the simple 0? They are not talking about the poles. First option, I can choose any value of the n. I can choose n is my 1. A1 z plus ag. Fine. At the point z is equal to iota k. So clearly say f dash. F dash is my a1, which is my non-zero, and for some, fine. So this value can be 0 because I can choose any value of the a naught like a1 iota k plus a0. If I choose k is equal to 1, fine. A1 is my iota. This is my minus 1. A0 I can choose as a 1. So then this part will go to the 0, but this part will not go 0 because a1 is iota. So yes, this is my simple pole. Look at the second option. F is my a sine 2 pi iota z. When z is equal to iota k, it is my sine of minus 2 pi k. Sine 2 pi k will be 0. We will find the derivative. It's a 2 pi iota a cos 2 pi iota z. Cos 2 pi k will not go to the 0. Yes, again it is my simple pole. Simple means order 1. Look at the third case. This will be f is b cos. I can open this bracket. It is 2 pi iota z minus pi over 2. Cos pi over 2 will be my sine 2 pi iota z, which is the same of this previous one. So yes, it is also the simple form. Fourth case, if f is equal to e raised to power c z, clearly say which is not goes to the 0 as z is equal to iota k. Fine. Then, or if it is goes to the 0, it is not goes to a 0, so that means it is not simple pole. A, B, C are my right answer of this problem. Okay. Or if you think about that it goes to the 0, then again you can think about another way, like e raised to power c of iota k. For some c, if I choose c is my say 2 pi, then exponential will never goes to the 0. Fine. So that means this will never goes to 0. That means no zeros. So if it is there is no 0, there is no simple 0. Okay, so December, which are the following 0, 0, 0? They are not talking about the poles. Remember, there is no need of this case. This is only applicable when you are talking about the zeros, singularities, or the essential. How you find the zeros? You can substitute this value as a 0. So that means e raised to power z is 1 over e raised to power z. That means e raised to power 2z is 1. So 2z is 2 and pi iota. So z will be n pi iota for all n in my z. Now since finitely many zeros cancel because n belongs to the no zero, only right option is D is my correct answer. Kindly like, share and comment on my videos to support my effort. F of z has a 0 of order. Again a very simple It's a cos z. I can take the LCM minus sin z over z. Then you can find the derivative. How you can find the derivative? I can take the definition of this. That could be easy at the point 0. Fine. So f of 0 is my 0. If you substitute them, it will be z cos z minus sin z over z square. Fine. Now firstly we will see whether 0 is the order or not. This value will, as the z approaches 0, 0, 0, 0. So that's a 0. Or you can see this value will be 1. Sin z by z is 1. 1 minus 1, 0. So 0 can never be odd. Now I can, again it's a 0 by 0 form. I can apply the L'Hopital rule. So it's a minus z sin z plus cos z minus cos z cancel out over 2z. Fine. So what is the answer of this? It will be 0. So that means f dash is 0. I need to find the second derivative. How you can find the second derivative? So I need to firstly find the first derivative. What is the first derivative is? Minus sin z minus cos z over z plus sin z over z square. Now this is my first derivative. Can you find the second derivative? Fine. So if the first derivative is also 0, that means the order 1 is not possible. Fine. Now can you find the second derivative? So I think that I will give you the exercise. Fine. You can find the second derivative and you will see this will not be 0. So once the second derivative is not 0, that means C is my right answer of this problem. Again, fz is given to be this one. G is my sine hyperbolic. Then it has a pole at z is equal to 0. It is already given as a pole. We need only as a order. So this is my pole denominator. I can substitute the value of the f. This will be my cos minus sin z. Now you can find the derivative. It is my z minus z sin z plus cos z minus cos z 0. So clearly say this value will goes to the 0 as z approaches 0. This value goes to the 0. H double dash is minus z cos z minus sin z. This what is the derivative is z. Kindly check the calculation whether it's a 0 or not. It's a sorry z into cos. If you take the derivative z into minus sine plus cos minus cos, that will be cancelled out. H dash will be this number. So then this is my, again it will be 0. If you take the third derivative, this will be minus z minus minus plus sine of z minus of cos z minus of cos z. Clearly say which is my non-zero, because cos 0 is 1, this is 1, this is 0. So the third derivative is my non-zero, order will be my 3. So C is my again right answer of this problem. Okay, now look at this one. Is a unit disk analytic of this. I can divide it by firstly n on the both side, 2 over 3 by this. Now it's a unit circle. I can define the new function g such that z will be 1 over n. Fine. So it is 2 over 3 plus z. Limit point of this is my 0. Fine. Limit point of this coincides, so that means f and g both are coincide by the identity theorem. So once this identity theorem coincide, then we can look about these options. F of 0 is 2 by 3. Both are same. What is the g of 0? 2 by 3. Simple pole. What is the pole? Firstly, we will see z approaches minus 3 of g. It is my infinity. Yes, it's a pole. How you can check about the simple? Because the degree is 1 is a simple pole. F of 3 is my 1 over 3. 2 over 6, 1 over 3, fine. If some student think about that, 3 is not the part of the domain, but make sure this is the identity theorem that they are the equivalent. Fine. No such function exists, but we already exist the function. So the right answers are A, B, C are my right answer. Again, you can define the function corresponding to this. If I divide by z, fine. So by the identity theorem, both are my same. So f of 0, which is same as my g of 0, g of 0 is my half. Again, pole, we will check about the limit at z approaches -2 of g, which is my infinity. Yes, it is my pole. F of 2 is my 1 over 4. Yes, no meromorphic function. That's a wrong answer. A, B, C are my correct answer. Okay, look at this one. This is the Mobius transformation. F is said to be the Mobius transformation. It's a very, very simple, but this is only one question I have seen in this Mobius transformation. But if you want to find the more lectures or the question on the Mobius transformation, look about my this lecture available at my YouTube channel. Now, what is the question suggested to you? H is a mapping function. H is a map from this on to. Fine. All those y is my greater than 0. This is the mapping from the H. This map on the unit circle of radius 1. Fine. Such that f of 2 iota, where is the 2 iota? This is my 2 iota. Fine. It map to the 0. Fine. That means this is my upper half plane. Upper half plane map to the unit disk. So by the Mobius transformation, what kind of the function is my obtained? E raised to power iota lambda z minus alpha over z minus alpha transpose. That is the only function which transform the unit, which transform the upper half to the unit disk. Now, what is the given to you? F of 2 iota is 0. So clearly say alpha will be my 2 iota. So that means e raised to power z minus 2 iota over z plus 2 iota, where lambda can be any real. Fine. Now this is my function. Now first one is a simple pole. What is the definition of the pole? We will check about the limit at z approaches -2 iota. So when z approaches -2 iota, it is my finite. This is 0, which is infinity. That is my pole. Fine. How you can check about the simple? Because the power is my 1, or if you consider that z is my denominator, then clearly say h dash is my 1, which is my non-zero. First derivative is non-zero, that is my simple. Now once it's a pole, it can never be essential. That's a wrong answer. Now look at the second option, f of iota. I need to calculate the f of iota. This is e raised to power, it will be my -3 iota over plus iota. That means -3 e raised to power iota times lambda. What is the value of the f of minus iota? It is e raised to power lambda. It's a minus of 3. Sorry, it's a minus iota. It's a, sorry, it will be f of iota. So it is minus iota over 3 iota. So that will be -1 over 3. When you take minus iota, then it's a minus of 3 iota over plus iota. That means minus of 3 iota times this. Then what is the value of the f of iota? F of minus iota complex conjugate. So -1 over 3 e raised to power iota into lambda minus of 3 e raised to power minus iota lambda. This will be cancelled out. This is cancelled. Answer is 1. Correct option. Now, look at the last option, absolute value of 2 plus 2 iota. So that is e raised to power. When you take 2 plus 2 iota, the numerator is 2, denominator is 2 plus 4 iota. This value is my 1, numerator is 2, denominator will be 4 plus 16. So 2 over 20, 2 over root 5, 1 over root 5, A, B and D are my correct answer of this problem. For more detail about the Morbius transformation, you can watch about my this lecture. If you are interested to find the entire function, identity theorem, all are in this my playlist of the YouTube channel Dr. Harish Garg. Kindly like, share and comment on my video to support. The residue of the function at the isolated singularity of the upper half. Can you find the poles? Because singularity means pole, z into z square plus 1, 0. That means z is 0, z is iota, z is minus iota. Only this case, the y is my 1, which is greater than 0. In this case, x is equal to 0, y is equal to 0, but we need a y greater than 0. This case, y is equal to minus 1, which is less than 0. Now clearly say z is equal to iota is my simple pole. Fine. So once it's a simple pole, how you can find the residue? That means either, because I have to find the z into e raised to power over z into z square plus 1. Fine. I can cancel out this. It will be e raised to power iota z, z into z plus iota. Now add the limit z is equal to iota. It is e raised to power minus 1. This is my 2 iota square. 2 iota square is my minus 1 over 2 e is my right answer of this problem. Right? This is a simple way you can solve this problem as a otherwise, or what is the other way? You can take the derivative of this function e raised to power divided by the derivative z cube 3z square plus z, that's a 1. Substitute the value at z is iota. So e raised to power minus iota 3 minus 1, that's a minus of 2. Again you will get the same answer. F is analytic function as a simple pole at z is equal to 0. So this is my fz. G is my analytic function. You can choose any analytic function. Let's say g is equal to 1. Then what is the residue of f into z? Fine. Can you find the residue of this? It's a single pole. So that means limit z approaches 0, 1 over derivative of this function, that is 1. Denominator is residue of fz. Again, this is same. So if you substitute this value, it is 1. If you look about that, z0 is 0. 0. Fine. G dash. G dash is my 0, but we need a 1. So G of 0 is my 1. A is my right answer of this problem. If you think about that, you can substitute z into 1 over z is my g of z. Again, you can see g of 0 is my 1. Then in that case, you can choose g is my any other number. Let's say z plus 1. This is also the entire function, and then you can substitute this, you will get as the 1. Again, you can see these options will be cancelled. F is a function has a simple pole at z is equal to a, such that so pole is given to you at z is equal to a. Your target is to find the residue at, so once is a simple pole, what is the shortcut tricks? As I told you, this divided by its derivative. Now you can substitute this value f of a over g dash of a. B is my right answer of this problem. Look at this another one. 1 over z into z minus 1 cube has a pole of order p. Can you find the poles? Pole is z is equal to 0, z is equal to 1. The order is 1, the order is 3. Fine. So P has order 1, that is a z is equal to 0. So can you find the residue at z is equal to 0? That means 1 over, this value will be my minus 1. So that means R is equal to minus 1 when P is equal to 1. Fine. Then when P is equal to 3, can you find the third order? So that means 3 minus 1, 2 factorial. Second derivative of z minus 1 cube into fz. That's the definition of the residue. So that is 1 over 2, second derivative of 1 over is z. So what is the second derivative of this? minus minus plus 2 over z cube. At the point z is my 1. When p is equal to 3, r is equal to 1, c is my right answer of this problem. Look at this function. Pole z is equal to -1 minus iota is the pole of order. Look at the denominator. Z square plus 2z plus 2. I forget the power 4. Whatever the order of this, I can multiply by 4. Fine. So I can divide them. 2z plus 2. When z is equal to -1 minus iota, what is the value of this? -1 minus iota. We will see whether it's a 0 or not. So it is 1 plus iota square plus 2 iota minus 2 iota plus of 2. This is cancelled, it goes to the 0. Look at this value, it's a minus 2 iota plus 2. It is not goes to the 0. That means this h has the order 1. Fine. This pole has order 1. Then this power 4 has order 4. 1 into 4 is 4 is the right answer of this. There is one more method. Instead of consider the power 4 separately, what you can do, you can think about this fifth, then you can find the h dash, h double dash. That will take a slightly lengthier method. So that's why I always suggested you this one. If z is a pole at f is a pole at z is equal to, then what is the value of this? If it is pole, then it goes to the infinity. Then only it has a pole. F is analytic. G is my analytic. You can choose G is analytic. At you can choose G is equal to 1. F is a pole of order K, Z minus E. Fine. Then you can substitute this value. Your target is to find the residue of G is my 1. So it's a F dash over F. Fine. So can you find the F dash over F? You can use the argument principle, number of the poles minus number of the zeros also. Fine. So that also you can do, like n minus p. Number of the zeros of this 0. Number of the poles is my k. So answer is minus k. So what is the g is my 1. It's a plus k. It is minus k. Minus k factorial. But we need a k. K derivative. Wrong. So the right answer is C is the correct answer. Or you can calculate the derivative. It will be minus k over z minus a of k plus 1 divided by z minus k of this. So this will be minus k over z minus a. So clearly say if you find the residue will be minus k. So again the right answer is C is the right option. The residue of this function e raised to power residue at z is equal to 0, because the denominator is not be given in a proper manner. The other definition of the residue is coefficient of 1 minus. So what is that? It's a 0. That means my target is to find the coefficient of 1 over z. I can expand this series. It's a 1 plus 1 over 2 factorial and so on. Fine. I can write e raised to power 1 separately. Then e raised to power minus 1 over z minus 1 over. Fine. Again, I can expand it. It's an exponential 1 minus plus 1 over 2 z square and so on, plus whole square over 2 factorial, whole cube and so on. Now, can you equate the coefficient of 1 over z? So you can see this coefficient is 1. Sorry, this is a minus 1. There is no coefficient of the 1 over z because the square, every quantity will be at least the square. The only coefficient is minus 1 over z into e raised to power minus 1, and that is my residue of this. So this is the way you can solve all these singularity question in a very, very simple manner. I hope you can like, comment and share my this video to support my efforts. Best of luck students. Happy learning all.